fact, for the past two, maybe 3 lectures, we've talked about having an environment where there's some sort of spatial option selected. I guess it really came to the fore last time. Our focus last time was on networks, but because a few types of networks and layout algorithms interact with spatial layout, I drew attention to this. So this is a continuous space, and it had a certain width and height here. Okay, so here it's 500 units across and 500 units down. Okay, that is associated with this. And you'll notice that there's other types here, but this is a continuous space. You'll also notice that these last two the columns and rows, are grayed out. They're not enabled. They're disabled from a UI perspective, and we'll see why that is. They're only germane to discrete spaces. So here we had a continuous space, and this continuous space allowed us to display the locations of these various items. And this is, in fact, a distance-based network of the sort we were working with last time. And we had these components on it by the vagaries of who happened to be close enough to whom to connect. And this was the continuous space. And an agent's location was picked using a uniform distribution in terms of its vertical and horizontal direction. And what you'll notice here is that by the vagaries of spatial statistics, you get some of these individuals very close to one another, sort of clustered, and others are sort of scattered far apart, right? Continuous space, they can be as close as they want. You know, if by chance two things landed directly on each other, that would be the luck of the draw, and there's nothing to prevent that or what have you. It's infinitesimally unlikely in a continuous space that they are precisely atop each other. They're probably off by a very small amount, but maybe visually we can't make it out, right? Okay, so continuous space. We've seen this before. We saw that last week. Okay, I'm going to talk now about discrete space in discrete time. And we're going to go into this in great detail.